In this video, we will explore section 7.3. Since this section is about computing the values of trigonometric functions of acute angles, those angles whose measure less than 90 degrees, then let us start a discussion about special angles. The angles 30 degrees, 45 degrees, and 60 degrees are called special angles because they have simple and exact trigonometric values that can be easily derived without a calculator. So I want you to be aware with this 30 degrees, 45 degrees, and 60 degrees in pi radian, which is pi over 6, pi over 4, and pi over 3. 30 degrees is for pi over 6, 45 degrees is for pi over 4, and 60 degrees is for pi over 3. Now let us locate these special angles in this first quadrant. So we have here 30 degrees or pi over 6 and half of 90 degrees, which is 45 degrees or pi over 4, and double of this 30 degrees, which is 60 degrees or pi over 3. They come from special triangles if you're interested to know where they came from. So this 30 degrees and 60 degrees comes from a 30 degree, 60 degree, and 90 degree triangle. This triangle is formed by cutting equilateral triangle in half, and the sides are in fixed ratio, which is 1 is to square root of 3 is to 2. And this 45 degrees or pi over 4 came from a triangle which is 45 degree, 45 degree, 90 degree, which is an isosceles triangle. It is formed by cutting a square in half diagonally, and the sides are in the ratio 1 is to 1 is to square root of 2. But anyway, when we evaluate the value of sine 30 degrees or 45 or 60 degrees, you will use calculator in finding this. Special angles are very useful in solving right triangles because they provide exact values for trigonometric functions. So let us solve right triangle. And solving the right triangle means finding all the sides and angles of the right triangle. So usually, one side and one leg are given, or two sides are given to solve the triangle. So let us have an example. For this example 1, when the instruction is solve the triangle, meaning we are asked to find all the sides and all the angles of this right triangle. Since this is a right triangle with this icon, meaning the measure of this angle B is automatically 90 degrees. And we have a given measure of angle C, which is equal to 60 degrees, and we can find this measure of angle A based from this. So as we know, the sum of all the angles in any triangle is equal to 180 degrees. So if angle B measures 90 degrees, the sum of measure of angle A and angle C, which are two acute angles, is always equal to 90 degrees, and they are complementary angles. So it means we can find the measure of angle A by subtracting 60 degrees to 90 degrees. So we will get measure of angle A, which is equal to 30 degrees. And then, since the hypotenuse is given, which is 10, so we can look for the side opposite of angle A, which is side A, and we can also look for the side opposite to angle C, which is side C. So first, to find for the side A, so this is the A, given the hypotenuse, and the A is adjacent to this 60 degrees angle, so we will use, so if we have adjacent and hypotenuse using SOHCAHTOA, so we're going to use the function which is cosine 60 degrees is equal to A divided by 10. Or you can also use, referring on this measure of angle A, which is 30 degrees, opposite over hypotenuse, you can also use sine 30 degrees, which is equal to A over 10. So if we will continue with this equation for cosine 60 degrees, so we can cross multiply to find A. So A is equal to 10 times cosine 60 degrees. Then you will make sure that your calculator is in degree mode, press cosine 60 degrees multiplied by 10, then it will give you A is equal to 5. And then to find for the side opposite of angle C, which is named as side C, we can use Pythagorean equation because we already know the hypotenuse and we already found this side A. So we can find C using Pythagorean equation, or you can use sine 60, or you can use the cosine 30 degrees. So we prefer to use this time Pythagorean equation. So the side C is equal to, since C is a leg, so that is equal to the square root of the square root of the hypotenuse minus the square root of this leg, which is 5 squared. So the answer for the side C is equal to 5 square root of 3. Now for this example, find the unknown variable as indicated. So in the given figure, the only variable indicated here is this angle x. So this is not the same as solving right triangle that we will solve all the sides and all the angles. So we would just find the unknown variable as indicated. And then it is added in the instruction to express our answer to the nearest hundredths. When you say rounding to the nearest hundredths means it is in two decimal places. So here, this angle x, we have 8.9, which is opposite to angle x, and 12.3, which is adjacent. So it means we can use the SOHCAHTOA, opposite divided by adjacent. So we can use the tangent function. So tangent x is equal to 8.9 divided by 12.3. And then to solve for x, we can use calculator using shift inverse or inverse tangent. Inverse tangent of 8.9 divided by 12.3, and it will give us an answer which is 35.89 degrees. As a real-life application of right triangle, which is angle of elevation and angle of depression, so we have here the vertical heights can sometimes be measured using either the angle of elevation or the angle of depression. So for the angle of elevation, if the person is looking up at an object and the observer is at the bottom, the acute angle formed from the horizontal line to the line of sight of the observer to the object is called the angle of elevation. While the angle of depression is if a person is standing on a cliff looking down at an object, the acute angle made by the horizontal line and the line of sight is the angle of depression. Let us have a real life application for that right triangle. So in this example, a 22-feet extension ladder is leaning against a building that makes 70-degree angle with the ground. So the question is, how far up the building does the ladder touch? Then we have to round off our answer in two decimal places. So let us draw a building and extension ladder that is leaning against this building. So this is the ladder and this is the building. And the ladder measures 22 feet. And this ladder is leaning against a building that makes 70 degrees angle with the ground. 70 degrees. This ladder makes 70 degrees angle with the ground. So this measures 70 degrees. And we're looking for how far up the building does the ladder touch. The ladder touch until here. So we're looking for this height, for this distance. So this is h. So now, as we can see here, we have formed a right triangle, and then we're looking for the height from the ground to the tip of the ladder that leans against the building. So since in this h is opposite to angle 70 degrees, and given the hypotenuse, so to find for h, we can use the function which is sine 70 degrees, which is opposite over hypotenuse. And from this, we can do cross multiplication. So h is equal to the product of 22 to sine 70 degrees. And just use calculator in degree mode. Then you will get the value of h, which is equal to 20.67 feet. So that's the answer for this h. So for another example, the angle of depression of a vehicle from the top of a tower on the ground is 60 degrees. If the vehicle is away from the building at a distance of 100 meters, find the height of the tower. Round off the answer to two decimal places. So here, let us draw a tower and a vehicle, and it says that the angle of depression of a vehicle, so the observer is on top, it is formed as 60 degrees. The angle of depression is the acute angle formed by the horizontal line and the line of sight of the observer. So this is the angle of depression. And then another given is the vehicle is away from the building at a distance of 100 meters. So we have here the 100 meters, which is horizontal distance. And then the question is, find the height of the tower. So in finding the height, we will start at the ground up to the top of the tower. So this is the unknown, which is denoted by h. So to find for h, uh, we form here a right triangle. And since the angle of depression is 60 degrees, so we have to find what's the angle here. And the angle here is formed is 30 degrees because the sum of these two is equal to 90 degrees. And if this is 30 degrees and this is 90, so this angle here is 60 degrees. So now in this right triangle, we now have 30, 60 degrees, and 90 degrees. And h is opposite to 60 degrees and 100 meters is adjacent to 60 degrees. So if I will refer to this angle, which is 60 degrees, we will use the function which is tangent 60 degrees is equal to the opposite of this angle over adjacent, so h over 100. Or if you are referring to this angle, which is 30 degrees, you can use the function tangent 30 degrees is equal to the opposite is 100 over the adjacent, which is h. So if we will continue this equation, we will do cross multiplication. So h is equal to the product of 100 and tangent 60 degrees. And then using calculator in degree modes, so h is approximately equal to 173.21 meters.